Hello, hello, hello. Today, I'm ready to tackle Advent of Code Day 11. As you can see, still got a few to catch up on, but I plan to use this weekend efficiently. Got my code. Yeah, this is my code. It's true statements now. Got my code running well. Let me shrink this. There we go. Code running, Quokka running, everything running. I am ready, and here we go. Plutonium pebbles. We have rules for some stones, numbers. Okay, you have this is my input. Okay, here's a longer example. Okay, so I have that many stones. So after blinking once, we become an arrangement of stones like this. Okay, so this is my example. That's a walkthrough of a single transformation, apparently. So this, after 25 blinks, you get this. So there's obviously an algorithm behind this that I need to do efficiently. How many stones will I have after 25? You said this was 25. I'll have that many. Okay. Okay, so we have constant stones equals data split on the space map to numbers. And then we have a for loop that happens 25 times. Forward focus for I plus plus. I imagine the part 2 will be cranking that I at 2024 times or something. Okay, the first stone becomes a stone marked 1. Okay, so wait, but those aren't the rules. Where are the rules? Okay, there we go. If it is engraved with the number 0, does that mean if it contains 0? It becomes a 1. Okay, I think this is literally just base casing. Okay. Um, so I guess I gotta go through all the stones and do things for let x equals 0, s less than stones, s plus plus. Okay, so if, whoa, not a page transition event. Eh, if stones, so I'm gonna put that in a variable. Stone, so if stone equals 0, stones s equal 1, else, let's do the rest of this stuff. So with a number and with the number, so I'm watching that change in grammar. With a number that has an even number of digits, if none of the other rules applies. Okay, so it's thing else. Gotcha. Okay, so even number of digits. Okay, so that's if stone to string length equals, well, modulo 2 equals 0. Eh. We do a thing and then we do the else. Okay, split. Okay, so we split it right there. Don't keep leading zeros. Okay, we got this. Cost. Now left stone equals, well, no. Left right equals to string dot. I need to split it in its half, so I'll leave this variable here, really. String. So, boop, boop. So, stone string, what is it? Split. I need to split at an index, though. Uh, Fine, I'll convert it to an array first. And then I'll. Why am I failing to figure out how to split a thing in half? Weird. Okay, I'll make just 2 lines. Constant left equals stone string dot slice 0 stone string dot length divide 2. Right equals stone string slice dot length divide 2, and we'll just see if I have left and right correctly. No, I have not. Well, stone string. Jeez Louise. 1, 7. What's my original stone string? 17. Okay, seems all right. It's doing the thing. We do that, and then we set the one here, and we also have to splice it in. So how do I want to do this? Stones, splice at my index, delete 2, and let's insert left and right, just for the giggles of it, because I don't want to do math. Otherwise, we're doing something else. So this is our third case. Multiplied by 24. Okay. Stones I times equal. Well, it seems simple. Supposed to do something at the end here. Oh, number of stones. Return stone. Right? 26 stones. Okay, I did something wrong. Oh yeah, this is only supposed to go for count equals stones dot length. Yeah, this is supposed to go for all of that. I've done something wrong. They're not multiplying, so we're never hitting this one. Weird. What's my... I eventually get some stones here, so I have to look at stones after each change. 1, 7. Well, 125, 1, 7. What happened? Everything went wrong. The 125 should have got multiplied, right? So, what? Let's put a break here. We don't need to see the other failures. Start with the first one. So we got 125. It's not a 0. It's not divisible. It should have got multiplied, right? So, yes. Okay, then we have 17. Then we have 1 and 7. Ooh, here's my problem. I did S instead of I. There we go. There we go. Okay, drop that. Drop that. Don't kill my computer. Be very appreciative. Thanks. Oh, it's going. Oh, it's going. So, 55,000. There's obviously some optimization here. Or this isn't running. Oh, it's a bunch of mans. Great. Batman. We love him. Who is the cause of this? It's gotta be this. Ah, right. You turn those into things that don't do that. Okay. What's the JavaScript way of doing that? So it's not plus. Well, plus works just fine. What are you doing? What are you doing? Are some of these left ones invalid? It's like this invalid? No, you handle that fine. These are perfectly looking valid. I mean, I'll look at the entire thing. 253, 253, 0, 2024, 2024, 24, 24, 220, 8096, 8096, 8080. What? So this seems perfectly fine. The multiplication's gotta be bad. It's not an array of numbers. I mean, let's look at it. Come on, not that one, that one. There it is, Batman. Undefined. Ooh, there's our problem. We do some undefining. We never delete stones. We only ever add them. Oh, freaking I did it again. So this is gonna work like instantly, I bet. 10. Nope, nope, never mind. Have any more eyes in here? No. You know, I hate this eye so much. I'm gonna make sure that never happens again. So I'm not doing the thing. After blinking 25 times, you have that many stones. I don't get that many. Did I leave a break? I mean, I guess I can look at these stones after each iteration, but I'm not seeing what I did wrong. Okay, fine. This is what I'm struggling on part 1. I'm not looking forward to part 2. Okay, so let's look at the first 6. So after 6 blinks, 2097 is my first number. 2097, this 41. Ah, I've goofed up. Okay, let's see. 1 blink is 253. 2 blinks is 253, 0, 2024. Okay, yep, the badness happened. It went bad. So I can just stop at 3. It's 3, break. Swap that up there. Yeah, you do that one right, but then the next one, wait, it's an underscore. So it's not this, it's 2, 1, not 21. Yeah, this is where everything goes wrong. Okay, so we're looking at this split 1 and the 17. Yeah, 1 times 2024, 7 times 2024. Okay, I see what those are supposed to be doing. Let's look at this stone. Yeah, so we got 253, we got the 0, we got the 7. I got the 0, return to a 1. Great, you did it. Well, hold on, why were you at 0? This ain't right. That ain't right at all. 25307, 25317. So what you start at? How'd you turn into what? Oh, 12517. That's the first iteration. Yep, I'm good. 25307. Oh no. 530. Okay, you're going too far. How did you go that far when I'm only on the first loop? Okay, fine. Stop at 0 then. We have 253, then we have 17, and we get 253, 1, and then 7. That works. Then we go through stones again in the second loop. And we have 253, we have 1, and then 7. And we go through it. The stone string, we do all 3 of these things. Oh, indexes. I move indexes. When I do the split, I need to go S++. You need to go forward to offset your thing. Right? Because you add 2 more, so you gotta move, maybe. I think that's better, but no. 25307. It's right in front of my face. One of those times, unfortunately, where I just can't see it. Might need to run through an actual debugger on this, to be honest. My brain can't see it. Let's. Wait, where is it? I'll do terminal. I said terminal. Where is it? There it is. Let's get in there. And let's just walk through this, because brain ain't braining, unfortunately. Dang it, I forgot I don't have this set up, apparently. Great. Can we turn it back on? Let's use this. It'll suffice. If triple equals 1, also log stone. Let's use that. Okay, so if it's this, then I do go through both stones, 2, 3. I do the split. I do two deletions. Let's do 1 deletion. Ah, there it is. 253, 0, 17. Okay, I think this works now. Everything was wrong. And it's 53, 0, 224, 7. That 7 not do its thing. Was I not supposed to do this? No, it's not making an impact. No, it is making an impact. It's, yeah, here's what I'm supposed to do. So I hit the 7. So where does the 7 go? Not there. 7 shouldn't go there. 17, yeah. 7 goes there. No, okay. Well, I processed the 7 at 7 point, right? Oh, because the count, because this is, okay, this does need to be dynamic, not non-static. Now we process the 7. Okay, I think we got it. Got something at least. Okay, now I think if I let it go, moment of truth. Let it rip. That's a number. And it's a fast one, so I'm happy about it. No, too low. Ow. Oh, so this is bad. I mean, I've been goofing up with so many little things, and who knows? Okay, let me make sure this is what I have after 6 blanks, because the count could be lucky for this one, but just not getting me the right actual numbers, which would make the count wrong for the real one. So let's look at. I have no idea why that input even ran. The weirdest thing I've seen. Why did that even run on an empty input? Must have parsed some zeros out. I have 6 seconds. I do agree, it is definitely too small though, compared to this number. Felt like 6 seconds to me. Boom, okay, part 2. 75. Okay, it's just, hopefully I wrote this not horribly inefficient. I don't, unfortunately, even see an optimization here. I don't even get an example. Just being like, hit it, 75. I hear a computer going. I might want to target this one directly. Don't listen to bug terminal. Yeah, it's too much for it. Concerning. Anything I can target here. I know Spice isn't that free. I know the stringification isn't free. Maybe I could do a check to determine if this. Let me just run it then. Right, so Wallaby's gonna take a really long time for that. You know what? If I run it on my initial, will I get an output? Because that'll still help me narrow down efficiencies. Not a lot, alright, but oh boy, come on. It's not that hard. Okay, maybe it is a bit hard. Let me look on the inside then. Let's see, back into 2024, back 11, and let me just drop a log on this. Oh, so it's great right at 25 where it starts to get like impossibly time consuming. Okay, so you have to look for pattern in the optimization. There could be cycles. Um, just looking with my eyeballs, and if I can see how long that wants to take, so we won't do that. Yes, I think I just need to look at this and see what I see, unfortunately. Lots of numbers. Well, even at 25, it's a lot. 3738. Oh boy, I don't think I'm gonna stumble upon this. If I find patterns, I can fast forward, is what I'm thinking. Like, if I find a zero, I know everything it will ever become, right? Like, if I perform 25 iterations on the zero, I'll know where it ends up. I don't know what I'm trying to say. I'm trying to say, like, maybe I optimize for the individuals, and then, yeah, so a zero will become this many. So if I ever get a zero, well, this many of that number. Does it scale? Um, so I guess I'm looking for stones dot length. It's a number that just keeps going up, unfortunately. 1 1 2 4 4 7. I'm seeing doubling there. So 1 1 becomes 2. 2 plus 2 becomes 4. 4, no. 7 7 14. So there is a doubling aspect to it. I can't feel the pattern though. If I could though, 0 1. I'm trying to see if I can find where it just straight up doubles. It seems to stop doing that actually. Okay, yeah, that was just in the beginning. Oh, that sucks. Um, I bumped that to 50. How long will that take? Oh, it's only zero, and whew, okay. I don't think that terminal is gonna go anywhere, unfortunately. There's a pattern. Just don't see it. I don't think there's a cycle. I mean, I know splice is expensive, but like, do old stones, new stones, that'd be memory expensive. I could only insert the new one, that'd be less expensive. I don't think optimizing for operations is the trick though. Gotta be something here. Zero is the only consistent thing though. So if I figure out how many zeros turns into at 75, every time I see a zero, I can be like, nope, you're not doing that. I feel like eventually everything does end up as a zero. I mean, maybe I could just be making stuff up, but yeah, 253, you times, then you have, then you times, then you times, and then eventually you'll have. Yeah, so I mean, tackling the zeros might just be enough. Let me spin up another terminal to try and get that calculated out. Fortunately, like I said, I couldn't see the math, but if I target this to 75, I'm just like, hey, let's, well, yes, solve. I should be able to follow you to 75, at least somewhat reasonably. Oof, you slowed down quick. Okay, there's got to be a difference between these. Length equals length there. Excuse me. Okay, so if I look at this, I look at the last length. So we have that. We have the actual one difference of them. Stone style length minus last length. It's not that big of a number. I'm not seeing anything. 3, 7, 2, 15. It goes down at one point. Ah, jeez. Oh, I do see that down up pattern. And then it stops. The down up pattern is literally 3 away from each other. So 19, 23, 19, 90, 2, 3, 4, 8, 1, 2, 2. Ah, can't see it. Are you gonna run? Oh nope, you're in the bowels. Okay, I need to see the pattern. This might just be a stumper while I'll come back to it. I need to look at the stones. So 124, 2020, 48. And then you get all the way, once you get zeros again, boom. Yeah, so it takes you 1, 2, 3, 4, a couple iterations to get you back to zeros. And then it begins all over again. So when I get a 0, I can just immediately skip forward to 0, 2, 4. All these other numbers, they gotta live their lives. And then they'll eventually come back to zeros, but uh, like I can fast forward the 0, but then I can't fast forward all these other ones because they're getting unique. Like now we got an 8, then we got all these. Okay, so for every stone, I keep track of its birth loop, maybe? No. You know what? There's some secret, super cool pattern of math, and I don't know it. So I'm gonna take a break and hope it comes to me. Yep. See you on the other side. I have returned and I have had an epiphany. Positions don't matter, the counts do. And what I mean by that is we don't care that 125 is in the 0th position. We care how many 125s there are. I believe there is a previous advent of code problem that had a similar solution of something similar to this. I can't remember, of course. But instead of counting, like, oh, we have a 253 in slot 1, a 0 in slot 2, this in that slot, this in that slot. We just count how many of these we have, and then as we perform the transformation of, let's say there are 5 2024s, and that results in 5 20s and 5 24s. And we just add those to the counts of the after blink state. That's basically the solution. It's not counting, like, lose the array construct completely and go with a hash map, basically. So let me actually implement that. Clock turned back on. Okay, it's a running. I'm gonna start killing all this because it's basically a rewrite where instead of we have an array of stones, we have counts, previous, next, and replace the old with the new. So, I mean, I could even go to the level and go for a full refactor, but we won't go there yet. So what we want to do is stone counts. Then we'll reduce this counts. Well, not that yelly. Stone, and then it'll be counts. stone, and that'll be counts stone, whoop, stone, or 0 plus 1. I think I'm missing some parentheses around here. I'm missing the types because there we go. Record string, well, it's record number really. That's not technically that. That's what TypeScript wants it. Boom, that's what we want. We have our stone counts. And for each of these, we go through the stone on the left side, form the value number of transformations on the right side. So this will be const new counts. Ta-da! And for const, I guess, stone count of entries. I can do an entries, yeah, that'll suffice. Stone counts. This will need to be a let. I'll need to do some reassigning. We will need the new logic here. So boop, boop, boop. Kind of like this. So at the end of this, we'll get the 2 stones. So I guess I'll make a tiny function called transform stones. Or what do they call it over here? Change stone number, and then we return a number array, because you could get 1 or 2. There we go. So we do this stone, we return, ta-da, your new stone. Apparently we need a stone string. Equals blah 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 stone to string. Good enough. And instead of splicing, we return left and right. Might as well. And here we return the stone times this, of course in an array, like so. So then we'll have our new stones. Const new stone of change stone old stone. Because this is a string. Let me fix that. If it's already a string, let's go for that. It's a string, not a stone. It means I can use double comparison, and I can just use the actual stone here because it will do that. Fine, we'll make TypeScript happy. No JavaScript would have dealt with that. Okay, so now we have our new stone. It'll be new counts new stone equals new counts new stone, or 0 to handle the undefined, plus old count. Spell the word. There we go. And of course, there's no typings on here, so let's fix that. Good. And now we replace the old with the new. Then we sum up all of the counts, which is the values of right here. Nah, something's broken. Oh, I think it's working. 19. Well, that's a 0. It's never going to work, and I will never know if it works. I'll never know if any of this works, because I don't have a test case, but we can try to shake this number and see if we're lucky. If we're not lucky, I'll make part 1 point to it. Boom! Lucky I am. Okay, so that's the solution. Yeah. Okay, well, it's kind of nice because we have both versions here, the old and the new refactor. So I'll be able to walk through them both. But let's start with the challenge. So our input is a space delimited string of numbers, and after every processing cycle, each of these transform into different numbers. And the challenge is to do it X many of processing cycles. So 25 for part one, 75 for part two. That's literally the only difference between part one and part two. As for each processing cycle, it goes through and it changes a stone to something else based on three rules. If the stone is 0, it turns to 1. If the stone is even, then the digits on the left side and the digits on the right side each become their own stone. Otherwise, you just multiply whatever the value is by 2024. Now they throw in some bold text here about order is preserved and blah blah blah. So yes, sure, maybe in the lore of the story, this order is very important. It's not for our problem. They go through it, but that's all there is here. And part two, again, same thing. That's the challenge. My code, thankfully we have both bad and good versions. We split the stones into that array of numbers. See that here. There are two of them in this example. And then we process the stone 25 times with this boring for loop. For each processing, we grab the current stone. We also grab it as a string for some other stuff. And we do our three different kinds of logic. If it's a 0, turn it into a 1. If it has an even number of digits, then grab the digits on the left, grab the digits on the right, replace the stone with the left one, and go ahead and add the right one in the same place. Then we have to do S++ so we don't process the new one we just added. Finally, the else case, multiply it by 2024. Lastly, you return how many stones there are. That's the challenge. And that works until you get to a higher number, which is where stone counts gets involved. So I'm actually going to just run this on. I mean, data is perfectly fine thing to run this on. Show how it works. So we'll show the initial stone counts. This is what it is. So you have your stone and how many of that stone there are. Now in this case, there's one of each stone. So how many 7s are there? There are 1. How many 14s are there? There are 1. Very unexciting. Then what you do is you go through these and you determine the new count. So if they're all okay, fine, we've got a 2. So yeah, here we go. So there are two 2024s. So if you perform the processing on 2024, you get 20 and you get 24. There are two of them. So you should end up with two 20s and two 24s, which is exactly what happens down here. And then apparently we get 3 zeros, which if we were to look, be able to track it down. Maybe I'm not able. Okay, here's one. So 80 becomes 8 and 0. So that becomes 1 0. And 20 becomes 2 and 0. That becomes 2 zeros. 24 also becomes 2 2s. So there are 4 2s and 2 zeros. Which if I look, 4 2s, 3 zeros. I did the math and I said the wrong number, but this is the efficient way of doing all of these counts, because we don't care about the numbers themselves. We care about how many times they are in the array, not their positions. So this just goes on and on forever. And yeah, I kind of explained it as I wrote it, but we go through the old ones, we grab the current stone, how many there are, we figure out what new stones that makes, and whatever new stones that make, we add however many old stones there were. Relatively straightforward. And yeah, if I was on my game, would have saw it in an instant, because this is literally pattern that at least one other admin of code has used in the past. But it's okay. With that, it's refactoring time. because we don't need that old solution anymore. Now, the only thing that really changes here is rounds or processing or blinks, as the lore calls it here. So it's this many blinks, and then we return how many we got. So this one is just 25. Solve data 25. As you can see, it's working beautifully. This is just return solve data 75. And I bet this could go even higher, right? Like 750. Ooh, we got a really scientific number there. As you can see, the efficient way. Now let's see where else I can squeeze some. This honestly is pretty much the best way of going through this. You'll be able to really reuse the same map because it's hard to track where you're coming and where you're going. We could do the counts outside of this. Eh, it just saves us a reduced call, honestly. It's not that expensive. Let me see about this change style, if there's anything I can make better here. Slice, map. Sure, I could fiddle with it, but it'll have no impact greatly. So I am fine as is, which means I'm good. Okay, this function belongs up here. Okay, now I am good. Yeah, like I said, just couldn't see the obvious writing on the wall. Got there in the end. Oh, looks like they always start with none. Okay, that's a fun fact. I was able to identify that because there's some branch here not being ran, and my only conditional on this line is this here. I'm going to leave that there because that's a better practice. Parentheses in the wrong place, though. Okay, now I am done. I just realized I never committed the raw version. Let's time travel. Oop, okay, this is it. So this is my solve code. And I'm going to fast forward before I lose it. And apparently I just lost it. Okay, well, it was obvious what my refactor code is. I'll re-refactor it to the same bit. But yeah, that was Advent of Code Day 11. And it was a pleasure, as always.